Hey, welcome back. In today's episode, I'm going to be talking about smart contracts. We'll be exploring what smart contracts are, their history, how they work, their types and use cases, benefits and challenges, and finally the tools used to create and manage them. We'll also be discussing how smart contracts are key in the tokenization of real-world assets, making this process accessible to every kind of investor, even enabling fractional ownership of tokenized assets. So let's begin. So let's start off with the basics. A smart contract is essentially just a digital agreement that is stored and executed on a blockchain network. Now, these contracts execute automatically when the predefined set of terms and conditions are met. Now, the terms are written in blockchain-specific programming languages, such as Solidity. Smart contracts are foundational to many blockchain applications, including non-fungible tokens, the famous NFTs, decentralized apps, and the metaverse. They actually enable automated, trustless transactions between two sets of parties. Now, a bit of history of the smart contracts. The concept of smart contracts was first proposed by a gentleman called Nick Szabo. He's a computer scientist in 1994. He described them as digital transaction mechanisms that execute the terms of a contract. However, the actual technology required to implement these ideas didn't exist at the time. So it wasn't until 2008, with the introduction of Bitcoin and its blockchain technology by Satoshi Nakamoto, that actually laid the groundwork. In 2013, Ethereum blockchain platform was introduced, making practical use of smart contracts possible. Ethereum today still remains one of the most popular platforms for smart contracts. Now, how do smart contracts actually work? What do they entail? Function similarly to traditional contracts, but are executed automatically via code. Now, here's the actual process. It starts off with an agreement where there are two parties that agree on the terms and conditions. It follows by actually creating the contract, so contract creation. So the contract is at that point actually coded, often with the help of a smart contract provider or developer. It then follows with actually deploying the contract, so it's actually published onto the blockchain, followed by monitoring, so the blockchain needs to start tracking the agreed upon conditions, and then followed by execution, where the contract executes a series of actions when conditions are met, and then finally recording the transaction and its outcome are actually recorded on the blockchain. So this process ensures transparency, security, and automatic enforcement of contract terms on the blockchain. Now, what are the types of smart contracts that are made available? Well, I can think of three smart legal contracts. That's the first one. Now, these are legally binding contracts that offer greater transparency and are often used for automating legal agreements. The classic example there could be will and testaments, or even commercial deal, which lays out the contract terms and conditions of the commercial deal. These are examples of smart legal contracts that can be published and made available on the blockchain. Decentralized Autonomous Organizations, DAOs. Now, these are organizations governed by smart contracts, giving voting rights and decision-making power to members without a central authority. And finally, application logic contracts, ALCs. Now, these involve code that interacts with other blockchain contracts or devices, which are often used in the Internet of Things or complex systems integrations. What are the top 10 use cases of smart contracts? You've got them listed here. So let's tackle each one in turn, because I think this is where the wind is blowing, just to appreciate what the applicability of smart contracts out there. So let's start off with royal payment and media and entertainment. An example could be where a new musician releases a song on a streaming platform. Well, a smart contract can automatically distribute royalty payments to the artist and the record label based on pre-agreed percentages whenever the song is streamed. So that's one example. Another one would be in the world of decentralized finance, DeFi applications. Now, an example there would be where a user wants to lend their cryptocurrency to another person. So they would actually use a DeFi platform where a smart contract automatically matches them with the borrower, manages the loan terms, and ensures repayment with interest without needing a traditional bank. Another example in the conversion of assets into non-fungible tokens, NFTs, would be where an artist creates a digital painting and mints it as an NFT on a blockchain. The smart contract at that point would manage the sale, the transfer of ownership, and any future resale royalties automatically. Another example in the realm of B2B data marketplace, well, take the example of a company that wants to sell anonymized consumer data. A smart contract on a data marketplace ensures that the buyer actually pays for the data and gets access only after payment is confirmed, maintaining transaction transparency and security end to end. Within the realm of supply chain management, an example there would be where a manufacturer uses a smart contract to manage its supply chain. So in this case, when raw materials are shipped by a supplier, the smart contract automatically releases the payment once the shipment is received and verified. In the realm of digital identity cards, an example here would be where an individual uses a blockchain-based digital identity for online services. So a smart contract in this case would verify their identity for service access without sharing personal information, protecting their privacy while ensuring authenticity. In the realm of electoral polls, so we're actually living through some major elections like in the US, in the UK, and France. So here the example would be quite simple, where a city conducts local elections using blockchain voting system. A smart contract in this case ensures that each vote is securely recorded and counted, preventing tampering and guaranteeing transparency in the election process. In the field of real estate transactions, an example here would be simple, where a buyer actually purchases a property and a smart contract handles the actual transaction. Upon receipt of the payment, the contract automatically transfers the ownership to the buyer and updates the land registry on the blockchain. In the field of healthcare data management, a patient consents to share, let's say, their medical records with a research organization. So a smart contract here would ensure that only authorized parties can access the data and logs all access to maintain transparency and privacy. And finally, in the area of civil law applications, so an example here would be where a couple uses a smart contract to manage their prenuptial agreement. So the contract automatically handles financial distributions and property ownership changes based on the agreed terms if certain conditions like divorce are met. So you can see the list here is only a subset of the true potential of smart contracts in terms of tokenizing these use cases onto the blockchain. And this list is growing extensively and quite rapidly. So you can start to see the huge appeal and true investment potential to actually realize these digital assets onto the blockchain. Now let's move on to explaining what are the benefits of smart contracts. Why, what benefit do they provide? Now, they actually provide, in my view, at least several significant benefits. You see them listed here. They are automatic in that it helps in the prevention of errors through the enablement of automated processes that help to minimize the risk of human error. So that's one first benefit. And the next one is trustless. Now, trustless is on the blockchain is by default. No need to trust the other party. The system enforces the terms automatically. All parties have access to the same data, thereby enhancing trust and security. Secure. So transaction details are actually stored securely onto the blockchain. It has a built-in backup mechanism which can help retrieve if needed. They are cheap in that no need for third-party verification or human oversight. And then finally, they are fast. The transactions occur in a matter of seconds to a matter of a few minutes, depending on the actual crypto asset that you're transacting with on the blockchain. So these benefits make smart contracts an attractive solution for many types of businesses and business processes out there. Now, what are the challenges of smart contracts? Despite the benefits that we just discussed a moment ago, smart contracts indeed face several challenges. So let's walk through them. Rigidity and inconsistent support. Modifying contracts are difficult. It's a difficult process, and support varies across jurisdictions. They are difficult in capturing unquantifiable data. So some industries actually struggle to use smart contracts due to the nature of the data that they manage and process. They conflict with GDPR, so this is the general data processing. The immutability of the blockchain can actually conflict with data protection regulations like GDPR. Skill shortage. Now, developing smart contracts is a brand new niche industry. It requires highly specialized programming skills that are in short supply at this moment in time. And then finally, scalability issues. The current blockchain networks actually do struggle with the volume of transactions compared to traditional systems. So addressing these challenges is crucial for the broad adoption of smart contracts out there in the real world. What are the top smart contracts tools? So this really is mainly aimed for the developer community. They're actually going to be programming smart contracts onto the blockchain. So let's go through a few of them. Now, Solidity is the primary programming language for Ethereum smart contracts. Remix is like a browser-based integrated development environment for developers to program smart contracts. Truffle is an example of an Ethereum integrated development environment. Hardhat is another Ethereum development integrated environment, and OpenZeppelin is like a library of secure smart contract templates. And finally, Ganache. Now, Ganache is a personal blockchain for Ethereum development, not really used for production purposes, but certainly for the pre-production, whether it's development or even testing smart contracts that's been developed. Now, these tools, as I've said, help developers create, test, and deploy smart contracts efficiently onto the blockchain. Now, what are the best practices for using smart contracts? Now, to maximize the benefits and minimize the risks of smart contracts, it's really important to follow best practices. We need to conduct thorough security audits. Now, this, for me, is the top best practice. So once you develop the smart contracts, you need to have an outside security audit firm to perform the audit of these developed smart contracts. That's to make sure there aren't any back-end loops or hacks developed and introduced into the smart contract. So that's the first thing I would recommend. The next thing I would say is you need to write clear and concise code. The shorter the code, the simpler it will be to maintain it. And the next one would be to use standardized templates and libraries. Third-party libraries is key. You need to then test the contracts extensively before you actually deploy them onto the blockchain. And then finally, you need to stay updated with the latest developments in blockchain technology. Now, adhering to these practices ensures that smart contracts are secure, reliable, and effective. Now, to wrap up this tutorial, smart contracts do represent a powerful tool for automating and securing digital agreements. They are pivotal in the tokenization of real-world assets, bringing greater transparency, efficiency, and automation to industries such as financial instruments like stocks and options, real estate property, arts and collectibles, legal documents, and many more, making this process truly accessible to every kind of investor, even enabling fractional ownership of tokenized assets. While there are challenges to overcome, the benefits are indeed substantial. Right, so that wraps up for today's episode. I hope you found it really interesting and you can start to see that's the true potential that smart contracts can actually offer, particularly in the process of tokenizing real-world assets out there, which are many, many. So the one thing is, in order to program these contracts, they need specialized skills, but even though the industry out there is still niche, there's only a handful of these developers that have actually these acquired skill set. They are growing in numbers. And please don't forget to follow best practices in developing these smart contracts. Make sure it's security audited by a third party and so on. So hopefully you've enjoyed today's episode. And if you do, please click on the like button on the video. And if you haven't done so already, please subscribe to this channel because I regularly publish high quality videos that I think could be of interest to investors out there. So until next time.